Let's take a look at one of the applications of integration. So it says find the area between these two curves and the x-axis. Okay, so what does that really mean? First thing, let's try and graph these functions. So I'm going to graph the line first, y equals negative x plus 6. We know that is a graph with a y-intercept at 6 and a slope of negative x. So it's going to go something like, a slope of negative 1, sorry. So it's going to go something like that. Great. Now what does, let's label that actually, so that is y equals negative x plus 6. Now in blue, let's graph what y equals x to the 1/2. Well, we should know that x to the 1/2 is actually the same thing as y equals the square root of x. So that, we should know, looks something like this. And it keeps increasing like that. So we can clearly see that this is the area we're trying to calculate because it's between the two curves and the x-axis. Great, so how do we do that? Well, there are a couple ways. First thing, when we hear about area, we need to think integration because really what an integral of a curve does from some point to another point is it calculates the area under that curve. So that's exactly what we're going to be doing. However, we can see that there's a couple ways we could calculate this. We can see that the area is under the blue curve up until this point of intersection, and then it's under the red curve to the right of that point. So if we wanted to do it based on area under a curve, so looking at it from a vertical standpoint, we would have to do two separate integrals, one for the first half and one for the second half. Another way we could do it is area. If we do it from side to side or look at it horizontally, it's the right function, the integral of the right function, minus the left function. But this can only be done if we do it in terms of y, dy. So we will also be running a definite integral there where y equals a to y equals b. Okay, so what does that mean? We can see that no matter where we are in this area, the right function is always the red line and the left function is always the blue curve. So maybe we can use this so that we only have to do one integral. First things first, we need to find this point of intersection here. So where does root x equal negative x plus 6? A couple different ways we could find this. We could actually square both sides and then we would get x equals x squared minus 12x plus 36. 0 equals x squared minus 13x plus 36. And we would get x minus 9, x minus 4. Equals 0. Okay, so we know that these two curves are going to intersect at x equals 4 and x equals 9. Well, not really x equals 9. It's actually going to be x equals, well, it will be x equals 9 if this curve were to continue, but we're only worrying about the positive square root. So we know that this point is where x is 4, and we should be able to easily see that y is 2 there because we're just taking the square root of x. Okay. So that means we're going from 0, because we want to start at the x-axis and count up, to a y value of 2. So our integral is going to be y equals 0 to 2 of our right function is the line, but we want that in terms of y. So instead of y equals negative x plus 6, I want to get x on its own. And this will just be x equals 6 minus y. So it's going to be 6 minus y as the right function, minus the left function, which is normally y equals root x. Again, I want to get x on its own, so it's going to be y squared equals x. So minus y squared, dy. Now we're ready to integrate. This is just a simple polynomial, so we know we go up a power, so it's going to be 6y minus y up a power to 2 divided by 2, minus y up a power to 3 divided by 3, evaluated from 0 to 2. When we evaluate from 0 to 2, we just plug 2 in for y, so it's 6 times 2 minus 2 squared over 2 minus 2 to the 3 over 2. And then we'll minus plugging in 0 for them all, which will just be 0. So it's minus 0. We don't have to worry about that. So we get 12 minus 4 over 2 is 2, minus 8 over 2 is 4, which equals 6. And we'll call it units squared because we know this is area. So the area of that green part is 6 units squared. Again, because we knew there was a constant right function and a constant left function all through the area, we used our areas in terms of y. We can do another example where we would go vertically instead of horizontally and get everything in terms of x, which is normally how the functions are presented. Hopefully this is helpful. You can always send us more questions. info@arnoldtutoring.com. Thanks.